Hello viewers, welcome to my channel, Second Math Hub, the solution to your math problems. We are still on trig, angle of elevation. Question 8, I read. A surveyor at sea level observed that the angle of elevation of the top of a mountain M, so meaning that the top of the mountain should be labeled as M. So this surveyor observed the angle of elevation from the top of the mountain from 2 points. And the points are N and P. And again, these 2 points are located on the west side of the mountain. So these are the angles of elevation. So from point N, the angle of elevation was observed at an angle of 16 degrees. And then from point P, the angle of elevation of the top of the mountain was observed at an angle of 18 degrees. So because of the word respectively, meaning that it was observed in the order in which the points were given. So N first, meaning that N angle of elevation is 16 degrees, followed by P, which is 18 degrees. So this information alone should guide us, represent something. So let's do that. So we have our sea level. This is our sea level, and this will be our mountain. This will be our mountain, simply because if there is our mountain, the right side becomes the eastern part of the mountain, and then the left side becomes the western part of the mountain. And we're told that this surveyor observed the angle of elevation from 2 points, and then these 2 points were located at the western part of the mountain. And again, we're told that the top of the mountain should be labeled as M. And don't forget that the mountain will meet the sea level at an angle of 90 degrees. Take note. So now these are the 2 points. One point as N, and then the other point as P. So with this we can observe the angle of elevation of the top of the mountain from these 2 points. Starting with N. What is the angle of elevation here? It was given as 16 degrees. And then the angle of elevation of the top of the mountain from point P was given as 18 degrees. So that is what we have done. Now if NP, that is the length of NP, the distance from point N to P, the distance from point N to P, this distance measures 1,600 meters. So that is the distance. And the base of the mountain, Q. So where is the base of the mountain? So there is the mountain, there is the top of the mountain, this is the base of the mountain. And the base of the mountain Q is vertically below M. So it means that this point here should be labeled as Q. We have to calculate the height of the mountain. So where is the height of the mountain? This is the height of the mountain. The height from point Q to M. So I'm labeling the height as H for easy calculation. And again, to make our calculation easier, I'm also labeling the distance from point P to Q as X. So from P to Q, I'm labeling the distance as X. So now, how many right angle triangles do you see? How many right angle triangles do you see? So you could see 2 right angle triangles. Now the smaller one, there is a smaller right angle triangle. So let's label them. So I'm labeling the smaller right angle triangle as triangle PQM. That is the smaller right angle triangle. Again, you can also see a bigger right angle triangle. This one. A bigger right angle triangle. I'm naming the bigger right angle triangle as triangle NQM. Triangle NQM. So take note of the two different right angle triangles. Now, we are looking for the height of the mountain. So how then do we calculate the height of the mountain using the smaller right angle triangle? So before we do that, we need to identify the sides of the smaller right angle triangle. I'm talking about triangle PQM. So now this side here becomes the opposite. Why? Because the height of the mountain faces the acute angle here, so that makes it the opposite. This distance here, line PM, represents the hypotenuse. That is the hypotenuse, simply because that is the longest side. Again, it is the side facing the 90 degrees angle. So obviously the remaining side becomes the adjacent. Remaining side becomes the adjacent. So now we have our, from the smaller right angle triangle, we have our opposite, we have our adjacent. So from SOHCAHTOA, which of them has opposite adjacent? So clearly that is TOA. So now from the smaller right angle triangle, that is triangle PQM. To calculate the height of the mountain, we must go by TOA. And what does TOA say? TOA says that the tan of the acute angle is 18 degrees must be equal to the length of the opposite. So the length of the opposite was represented as h divided by the length of the adjacent, which is represented as x. I want us to make x the subject. So tan 18 is the same as tan 18 on 1. You can cross multiply. X times tan 18. X tan 18. And then 1 times h. That is h. So to make x the subject, you can divide both sides by tan 18. So tan 18 will cancel out, leaving x is equal to h on tan 18. So I'm naming this equation as equation 1. Now from the bigger right angle triangle, let's label the parts or the sides of the bigger right angle triangle. So from the bigger one, that is triangle NQM. This side here is still the opposite because the height of the mountain faces the acute angle, which is 16 degrees. So this height here, or the height of the mountain, is the opposite. This distance here, that is line NM, also represents the hypotenuse because it is the longest side. Again, it is the side facing the 90 degrees angle. So obviously, this side here, line NQ, represents the adjacent. The whole of this distance here represents the adjacent. So to calculate the height of this mountain using the bigger right angle triangle, that is triangle NQM. Triangle NQM. We have our opposite and we have our adjacent. So opposite, adjacent. From SOHCAHTOA, we still have to use TOA. And what does TOA say? What does TOA say? So now, from the bigger right angle triangle, that is triangle NQM. So the tan of the acute angle, so the acute angle from the bigger right angle triangle measures 16 degrees. Is equal to the length of the opposite. So the opposite is still the height of the mountain divided by the adjacent. Which side is the adjacent? So this line here, line NQ, is the adjacent. But we see that the adjacent has been split into two. One part measuring 1,600 meters and the other part measuring x meters. So the total distance here becomes 1600 plus x. So again, we want to make x the subject. So tan 16 is the same as tan 16 of 1. So we can cross multiply. So we have 1600 plus x multiplying tan 16. And this should be equal to 1 times h. That is h. So we can expand. 1600 times tan 16. 1600 tan 16 plus x times tan 16. X tan 16. And this must be equal to h. So now let's make x tan 16 the subject for now. So we have x tan 16. This should be equal to h. So when it crosses the equal sign, it becomes minus 1600 tan 16. So at this point, you can divide both sides by tan 16. So here by tan 16, the whole of this by tan 16. So tan 16 will cancel out, leaving x is equal to h minus 1600 tan 16 all divided by tan 16. So I'm labeling this as equation 2. So we have our equation 1 and then equation 2. So this is our equation 1 and this is our equation 2. So now we see that we have in equation 1 we made x the subject, and in equation 2 we made x the subject. So x must be equal to x. So at this point we can equate equation 1 and equation 2. So let's do that. Let's equate the two equations. Equation 1 we have x, equation 2 we have x, so x must be equal to x. So equation 1 we had h on tan 18. This must be equal to equation 2, h minus 1600 tan 16 all on tan 16. So how do we solve for h? So we can cross multiply. So what is h times tan 16? So we have h multiplying tan 16, and then this one to tan 18 times the whole of this expression. So h minus 1600 tan 16 times tan 18. So let's expand. So h times tan 16, that should give us h tan 16, and then the whole of this expression multiplying tan 16. So we have two terms here. So the first term here, h, will multiply tan 18. That should give us h tan 18 minus the second term multiplying tan 18. So 1600 tan 16 tan 18. We are looking for h. So let's group all h on one side. So I'm transposing h tan 16 to the right, and then negative 1600 tan 16 tan 18 to the left. So this one here becomes positive when it crosses the equal sign. So we have 1600 tan 16 tan 18. The whole of this must be equal to, so on the right I have 8 tan 18, then minus h tan 16. So now we have 1600 times 16 times 18. You can factorize h out. You can factorize h out. So h leaving tan 18 minus tan 16. So since we are looking for h, you can divide both sides by tan 18 minus tan 16. And then this side too, we divide by tan 18 minus tan 16. We are almost done. So tan 18 minus tan 16 will cancel out. So we have the whole of this should be equal to h. So let's simplify this. Let's enter the whole of this expression into our calculator's memory. So we have a fraction here. So the numerator, we have 1600 times 16 multiplying tan 18. Make sure you close the bracket, else it will give you math error. And then for the denominator, we have tan 18, you close the brackets, minus tan 16. Okay, so I'm having 3905 point, so to 2 decimal places, 0.00 is equal to h. So finally, the height of the mountain is equal to 3,905.00 meters. So that is the height of the mountain. The question demands a lot from us, but if we follow the procedure, it won't be difficult. So this brings us to the end of today's episode. If you haven't yet subscribed to my channel, talking about YouTube, so this is the name of the channel, Second Math Hub on YouTube. And then when you enter the channel, the first thing you do is to subscribe to the channel, so that anytime I post a video, you get the notification on your smartphone. Thanks for watching. See you next time.